Okay, if we get to the next problem, well, there are a couple of ways I could do this, and I'm going to show you of a shortcut, but I want to make sure that you know how to do it without the shortcut, in case you've forgotten. So in this case, I already know how this is going to work. I'm going to have to use integration by parts 3 times. First attempt, I'm going to let u equal x cubed, and I'm going to take a derivative of that. That's 3x squared dx, which means dv must be whatever is left over, and that would be the sine of 2x dx. So if I integrate, what do you take a derivative of to get sine negative the cosine of 2x divided by 2? This is going to equal u times v, and somebody made this observation, u times v minus the integral of v du. So if you take those and you multiply 3 times 2, negative times a negative will be a positive, just to save time. And 3 times a half is 3 halves. The integral of x squared, the cosine of 2x dx. So this piece right here is pretty much done. Not much to do. But this right here, if I let u equal x squared, du is 2x dx. And if dv equal the rest, cosine of 2x dx, then if I integrate, v would equal the sine of 2x divided by 2. u times v minus the integral, if I multiply those, u dv, the 2's cancel out, so I'm left with x, the sine of 2x dx. And if I proceed and do this one more time, so now so far I have negative x cubed over 2 cosine of 2x plus 3 over 4x squared the sine of 2x minus 3 halves the integral of x the sine of 2x dx. On the third attempt, I could pretty much be done because I know if I let u equal x, du is dx, which means dv must be the sine of 2x dx, integrate, and v would be negative the cosine of 2x divided by 2. So far I have negative x cubed over 2 the cosine of 2x plus 3/4 x squared the sine of 2x minus 3 halves times u times v negative x cosine of 2x divided by 2. I need a bit more space. I have plenty of space. There we go. No need to switch anything. Minus the integral of v du. Well, you notice there's a negative there. Negative times a negative is a positive. I'll take the 1/2 up front, and I have a cosine of 2x dx. And this tells me, you know what? This is negative x cubed over 2 cosine of 2x plus 3/4 x squared the sine of 2x plus 3/4 x the cosine of 2x. Now when I integrate this, wouldn't that be the sine of 2x divided by 2? So if I take the 2 there times the 2 there, that's a 4, times the negative 3 halves, that becomes a negative 3/8 plus c. And there it is. Somebody made this observation and said, okay, you know what? Let me see if I could fit those here. And with the new technique, I really don't need that much space. You're going to be very impressed, I think. Somebody looked at this and said, okay, why don't we you know what? I have plenty of space. Let's go this route. That's easier. Or somebody looked at this and said, you know what? Here's u. You're going to let u equal x cubed. And the VB, kind of like the first setting, the sine of 2x, take a derivative, take another derivative, take another derivative. The idea is you keep on taking derivatives until you get a 0. And integrate. Integrate again. Negative the sine of 2x. When you divide by 2, you're multiplying those, that's a 4. Integrate again. And integrate one more time. Nope, no negative. And this is what they figured out. That resembles this, 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 and the last is this. So multiply that way. Start with a positive, you multiply by a positive, and you alternate the signs. And guess what that gives you? That gives you the yellow part, negative x cubed over 2, the cosine of 2x. When you multiply the blue part, negative times negative is a positive, 3x squared over 4, the sine of 2x. The green, when you multiply, that is 6x divided by 4 if you simplify, 3x over 4, the cosine of 2x. And when you multiply, that's a negative. 6 divides 16, so by 2, that's 3, the sine of 2x divided by 8 plus c. Somebody figured this out. Look at this answer right here. And look at this answer right here. How do you like that trick? So this I could use, if I have to use an integration by parts more than once, that's probably the best way to go. Let me demonstrate with another example. I already have everything. It's kind of hard to fit stuff. So you don't need that much space at all to do this. This is a shortcut. If I take this problem, well here, if I let u equal x to the 4th, take a derivative, take another derivative, another, another, and another. dv is going to be e to the x. Integrate, integrate, so you line them up. Integrate, 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 and integrate. You always start that way. Start with a positive and alternate. And you'll notice that if you do this integration by parts 4 times, that takes a long time. Or you could simply say that is, if I go by the yellow, blue, green, orange, then yellow again. The first yellow will give me, the answer will be x to the 4th e to the x. The green, positive times a negative 4x cubed e to the x. I'm sorry, the blue, not the green. Now the blue plus 12x squared e to the x. The purple, not the purple, the pink. And the last yellow. And that saves you a lot of time and effort. So one type of the problem, there are really 3 types of problems. One type, you do integration by parts once, you really don't need a shortcut. You could just do it once, you're done. Second type of problem is when you have to do integration by parts more than one, apply that formula. The third type are general problems. One of them is a star problem, and that would be this, I. We'll get to that in a minute. But for now, this. a key problem in integration. Anytime you look at a problem that you're trying to integrate, if you see a log of any base or any, not trig function, inverse trig function, it's always u equal that. No exception. No exception. If I see a log of any form, or if I see an inverse trig function, I always let u equal that. I try a u sub first. That doesn't work. Which means if the u sub doesn't work, dv must be the leftovers. Integrate. So this is going to equal u times v minus the integral of v du. So that's the 1/3 I take up front. And 1 over x, that's x squared dx. I'm done. If you add 1 to the power, you divide by 3 times 3, that's a 9. There it is. That's what you take a derivative of to get x squared times natural log of x. And if I look at h, again, I look at that problem. Those problems are easy to do in the sense that you know exactly how to do them. You're going to learn all of these different techniques of integration. You see a log or an inverse trig function, you know either a u sub or integration by parts. Always work. Let u equal the arctangent. Take du and see if it's just a u sub. That's 1 over 1 plus x squared dx. Well, we have a problem. There is no 1 plus x squared anywhere in there. So we're going to go for parts. dvb, if I let u equal this, dv must be the leftover, whatever is left over. Integrate, and v equal x. So this is going to equal u times v minus the integral of v du. That is x over x squared plus 1 dx. Here, I'm going to let u equal x squared plus 1. du is 2x dx. Guess what? This is not integration by parts. I let this be u. And I notice I need an x dx. X dx will be du with a 1/2. So this is x arctangent of x minus 1/2. Isn't that natural log of absolute value of u? And what was u? U was x squared plus 1. And that would be my answer. Now, calculus students normally dislike the last question. And they really don't get to see the application of it. Lucky for you, we're going to see the application for this problem when we get to the differential equation part of this course. So this, there's no way around it. You're going to have to do integration by parts twice. The shortcut doesn't work on this because when you look at this, I mean, you could use the shortcut, but then you have to modify it, and let's not go there. So if I glance at this, I'm thinking, well, if I let u equal e to the x, that will never go away. And if I let u equal the sine of x, that will never go away. So how does this work? Well, it turns out you have to do integration by parts twice, and you'll get this exactly back. And let me demonstrate. So here you have your choice. Since you cannot eliminate an exponential by taking derivatives, or trig function by taking derivatives, it doesn't matter what you let u equal. It's up to you. If I let u equal the sine of 2x, which is fine, du is twice the cosine of 2x dx. That means dv must be e to the negative x dx, the leftover, right? And of course, you could have let u equal e to the negative x and dv equal the sine. But I find that students find it easier to take derivative of trig than integrate. But whatever works. Isn't that e to the negative x? Dividing by a negative 1 just makes that a negative. So first equal u times v, negative e to the negative x, the sine of 2x, minus the integral of v du. So I have a negative that becomes a positive. I'm going to take the 2 up front, and I'm going to have e to the negative x cosine of 2x dx. That's first round. Second round, I let u equal, you want to be consistent, the trig function, the cosine of 2x. du is negative twice the sine of x dx, which means dv is whatever's left over. And if I integrate, v would be negative e to the negative x. So this is going to equal, if you notice, negative e to the negative x, sine of 2x is there. There's a 2. Whatever comes out of that integral right there is this part. u times v, negative e to the negative x cosine of 2x, minus the integral v du. Do you notice this is negative times a negative, which is a positive, times a negative, that's a negative? I'll take the 2 up front. E to the negative x times sine of x, sine, oh, I forgot the 2x, sine of 2x. Now, I'm going to skip the middle part. I'm going to copy the left. This says the integral. I'm trying to figure out what this integral equals. Skip the middle part and copy the left side. That is negative e to the negative x sine of 2x minus 2 e to the negative x cosine of 2x minus 4 the integral of e to the negative x sine of 2x dx. Now, do you notice that this and that are exactly the same? If I move this to the left, I have one of those. When I move this to the left, it becomes a positive. Plus 4 of those. Isn't that 5 of those? That's kind of like me saying x equal c plus d minus 4x. If you move this to the right, doesn't that become 5x? And I'm just going to copy this down. That is negative e to the negative x sine of 2x minus 2 e to the negative x cosine of 2x. And wouldn't this integral, what I'm looking for initially right there, sine of 2x dx equals 1/5? Now, you could write it as is. You could say negative 1/5 e to the negative x sine of 2x minus 2/5 e to the negative x cosine of 2x plus c. There is nothing wrong with that. And again, calculus students don't know why this happens. You're going to know because you're going to figure out whether this converge or diverge. We'll talk about that later. I factor the 1/5 on the negative and the e to the negative x. That's going to be the sine of 2x plus twice the cosine of 2x plus c. Now, of course, you don't have to go for the blue part. Anything that I box is an acceptable answer for me on the homework, on the exam, but most likely the back of the book will look like this. But this is fine. And that concludes this section.